Hello dear students, today I am going to show you problems on simply supported beam with point. How to solve this problem using ANSYS software. Before that one, look at the problem description. Draw shear force and bending moment diagram for the beam shown in figure. The beam shown is simply supported with the load exactly at the middle. So to solve the problem, they have given the angular rectangular cross section of the beam is 200 into 300 mm and Young's modulus value is 210 into 10 raised to 3 Newton per millimeter square. Poisson's ratio is 0.27. So as we can see in the image, the beam is simply supported. In analytical method, while we are solving, we have to solve the reaction forces first. We can look at the solution here. I have solved the reaction forces at point A is 10 kilonewton and similarly force at B is also 10 kilonewton. You go through the detailed solution. After that one, we have solved for force at A, force at B, and force at C, respectively. A and B are the supports, and C is the midpoint. After that one, moment at A and moment at B is 0 since both are support point, and in the middle, the moment is 20 Newton per meter. Here, it will be 20 kilonewton per meter because the load is 20 kilonewton. So after these values, we can analytically draw this diagram that is indicating shear force and second diagram indicates bending moment. Let's solve this problem using ANSYS software and validate our answer. So ANSYS interface I have opened. As usual, you select preferences, structural, click OK, go to preprocessor, element type, add, edit or delete. Add, you select beam option here. In beam you select 2 node 188, click OK. So here it will appear beam 188. Then close this menu. Select material properties. In that one material model, go to structural, linear, elastic, isotropic. Enter the value as per the given problem, that is 210 e power 3 and Poisson's ratio value is 0.27 as mentioned in the problem. Click OK. Close this menu. Then go to sections. Select beam. In beam common section. As per the problem definition, the breadth of the section is 200 mm and height is 300 mm. Enter 300 and then click OK. So after that one, you select modeling option. In modeling, you go to create. So carefully observe, we have to create key points here. Select key points in active CS. So here enter number 1 and value as 0 and press apply. So as you can see, the beam is like this. We are selecting these 2 points. You can select from either A, B and this one. So that is the reaction, no problem. I am taking this point first one. So here there is no distance. I am entering 0 and applied ones. So select key point number 2, that is the middle point, key point number 2 at a distance of 2 meter from this support. So you enter 2 and distance is 2 meter, that is nothing but 2000 mm. Click on apply once. Then change the key point number 3, that is at a distance of 4 meter away from the starting point. So here enter 4 meter, that is nothing but 4000 mm. Key point number is 3. Click on OK. So you press fit view here. So you can see node number 1 or sorry key point number 1, key point number 2 and key point number 3. After that one you have to create the element, go to lines, straight line, click 1 and 2 and again 2 and 3. After that one you click OK in this menu. So as per the basic concept of FEM method, we have to do meshing. So go select meshing option. In that one, size control, take manual size. In that one, global, then again size. So we are dividing the beam into number of parts. You can click 10 here and 100 to get a more precise result in number of element divisions. Click OK. After that one, you select mesh. In mesh, select lines. Select both the line. So you can clearly see the portions are breaked as per the given value. Then click on OK. So the line is again measured. You can see the numbers are missing. Key point numbers are missing. So to clear that one, you go to plot and again click on lines or key points. You select lines so that you can easily differentiate the lines. Click on lines. So it will be displayed with the two colors indicating the middle point. So now you are supposed to apply the load. Select on loads, then select define load. In define load, you select apply. Again in apply structural. In structural, select displacement. So on key points. So carefully observe in the given problem. So two points are simply supported, point A as well as point B. For that, you select this point A as well as point B at a time. Click on apply. So as we have told, for simply supported beam, you have to select UX, UY, UZ, ROTX, that means rotation in X direction and rotation in Y direction. Only you have to leave ROTZ option without selected. That means remaining all option in X direction, Y direction, and Z direction, and rotation in X direction and rotation in Y direction, all should be selected. Click on OK. So you can clearly observe two triangles will appear at both the end, and at the middle there is a force. You select force bar moment. On key point, you select this middle portion, apply. The value is in Y direction because in the given problem load is applied in the Y direction and the load is downward direction. That's why I select negative. So minus 20 kilonewton, that means 20 E3. Click on OK. The center arrow will come, which is indicating in downward direction. So load is applied, then go to solutions, solve. In solve, you select current LS, click OK. The solution is done will appear. So if solution is done is appeared, indicates all steps are followed correctly. Then close this one. If solution done is not appeared, you have to follow the steps again, indicating all the points and parameters given in the problem. Close this one. Then we need to get the result here. For that, you go to general post processing. So before plotting, you can just list the result to get the reaction forces. If you want to check out the reactions, you go to list results. In that one, reaction solution, reaction in Y direction, click on OK. See, as I told, you can clearly observe the reaction as 10,000 and reaction at 2 is also 10,000. As we have solved in the problem, reaction at A is 10 kilonewton, that is nothing but 10,000 Newton. Reaction at B is also 10,000 Newton. Reaction at supports. But we need shear force diagram and bending moment diagram. For that, you have to define the table. Go to element table, define table, add, select by sequence number. SMIS is selected. Enter number 3. Click on OK. So here you have to get number 3, but it is not coming. That means you have to observe the screen carefully. There is one error message. This requested database is not available. No need to worry. Close this one and close this one also. When you get the error, in command prompt you type set, comma, last, click enter. Then again try the same steps, element table, define table, add. Here you select by sequence number. SMIS is given. Enter number 3. Click on apply. See clearly the 3 is appeared here. Then again follow the same step. By sequence number SMISC. Number 6. Apply. Again by sequence number SMISC. Enter 16. Click on apply. And last step by sequence number SMISC. Enter number 19. Click on OK at the last step. You have to enter 3, 6, and 16, 19 as I told in my earlier videos. So 6 and 16 combination is used for shear force diagram. 3 and 16 combination is used to get bending moment diagram. Close this one, then go to plot results. Select counter plot in that one line element result. Select SMIS 6 and SMIS 19 for shear force diagram. Click on OK. So clearly it is indicating the maximum load is 10,000. So it is also 10,000 and here 10,000. So we have got this one exactly as we solved in analytical problem. Sometimes the reverse image may reverse. You no need to worry. That is also same with another sign convention. But in this one, we are getting exactly similar answer indicating the values. So here the value is 10,000 positive and here 10,000 negative. So we have solved for set A is 10,000. So for set B and C both are negative minus 10,000 values. So again to get bending moment you select go to line element table, select the combination of 3 and 16. 3 and 16, click on OK. So clearly look at the bending moment diagram. So this resembles our analytical solution with the value. You can clearly observe the value here, 20 kilonewton meter. Here also 200 into e power 08, the maximum value it is observing. In another unit, it is given in Newton millimeters because the values are entered in Newton millimeters. So this will exactly show the result of SFD and BMD. So if you want to see the real bar, how and its animation, you go to plot control, style, size and shape, display of element, you make it on, click OK. Then go to plot control, animate, in animate, go to deformed result, click on OK. So the result is going to see this one. If you need 3D animation is appearing. If you want an isometric view, you can click on isometric view also. So as I told, this is a simply supported beam. Beam is supported at both the ends. That's why the load is applied at the center. Beam is bending like this. You can just increase or decrease the frame to get the speed movement of the beam bending. Thanks for watching.